Okay, so we start. Alright, so we were talking about enough. So we were talking about A star search. Right, we were talking about A star search. So A star basically takes both UCS and information from greedy into account. Okay. We had talked about this, but we'll continue from here. Right. So let's redo this. This is the problem that is given to us. We are supposed to find the shortest route from S to G, and we had built this search tree. Okay, from S you can go to A, from A you can go to B, and so on. So this is the search tree that we have. Question is, how do we do this using A star? By the way, if I were to do DFS here, what will I do? This path first, then come back, and here I'll find it. If I were to do BFS, this level, and then this level. What about UCS? UCS will take me where? The correct G, because I will first explore for 1, then for 2, then for 3, and after 3 I have 4, I'll go here, and after that I don't have 5, I have 6, right? So UCS of course is complete and optimal provided all my weights are positive. Okay, now in case of A star. In case of A star, you keep track of two quantities, G and H. In this example here, H is given to us, but in general you will have to figure out what should H be for your problem. As the course progresses, that becomes a question for us. In fact, there will be questions on maybe next midsem on this, that how do you design H for various problems. So we start from S again. Right now I have not explored anything. What is in my fringe? S. What is my strategy? A star. A star explores in the fringe based on this sum Gn plus Hn. Okay. So every node has both these values Gn and Hn. They are here. For start, G is 0, H is 6. So G plus H is 6. So we are here 6. But to start with, I don't have a choice. I start from the root node. I expand this. I expand S. I still don't have a choice. I go to A. So my fringe is now A. I come here. So at A I have G1, H5, whatever that might be. Once I have explored this, expanded this, what is there in my fringe? B, D and E. So this is my fringe now. Where do I go and explore? This is 8. Why 8? 2 plus 6. So anybody who thinks they are not with me, all I am doing is I am just adding these two values, and उनमें से जो सबसे कम है, just go there. Okay. So 2 plus 6 is 8, this is 6, and this is 10. B, D and E are in my fringe right now. Which one do I explore first? D, I go to D. What is my fringe now? Once I expand D, what is my fringe? B, G and E, right? These guys. Now what do I explore next? 8, 6, 10. I explore G. Have I reached G? So I have reached G, fine, done. Any questions here? So A star takes me to the optimal goal. Okay. So A star works. G is given to you. So in that Romanian map problem, G is the cost that was given to you. G is that cost which you are getting from UCS. So that is given to you in the problem. By given, I mean, let's say if you were the first one who was doing Google Maps, then of course you have to do that on your own. Okay, next. So this works. Tell me what happens in this case. Run karo apni notebooks mein. So right now I start with S. My fringe contains only S. So I hope there are, yes. So my fringe is S. What is G for S, by the way? 0. So G is 0. What is G here? And so on. Okay. What is G here? What is G here? So G here will be, so let's do this. And particularly those who think they are not getting, this is the right time to bring your focus on H. In reality it will be the other way round. आपको H नहीं given होगा, you will be given G. In this case also you are given G. My question is, I want you to give me G at each node. G is equal to 0 here. Why? Root node, start state, right? What about this? G is 2. What about this? G is, what about this? 4 or 5? Why 4? And why will I go for optimal? मेरे को पता होता तो मैं यही नहीं कर लेता. What did you say? G cost, right? And UCS will give you optimal. So this is G equal to 4 here. Okay? G is the lowest cost from the starting. नहीं समझा क्वेश्चन ही नहीं समझा. So that's what we are saying here. Look at here again. What is GN? Uniform cost. So UCS जो आपको हमेशा cost दे रहा है, that is the minimum cost. So G will be 4 there. Greedy is something that you are finding. So G equal to 4. Okay. Now run this. So at the beginning I have just S in my fringe. What do I do? Expand S, and where do I reach? So what is there in my fringe now? A and B. Okay. So I had G equal to 0 here and H equal to 3 here. Whatever these values are, I don't have a choice because I have just one node in the fringe. यहाँ पे बताना भाई. A में G equal to 2 and H equal to 2. यहाँ पे H equal to 1 and G equal to 2. Which one do I go? B. All right. So अभी फ्रिंज में ये दो थे, I have expanded B and there is a G here. Okay, what do I do next? What is in my fringe now? A and G. Okay, and what are these values for G? G equal to 4, H equal to G is 5.
Yes sir, प्लस 3 हो जाएगा ना सर, वो ऊपर वाले के पास के लिए 4 होना है।
ओ
और नीचे वाले में 5 है।
ऐसा, let's keep G equal to 4. You won't have multiple values of G for every node, right? G is defined as the UCS cost, which is going to be a unique cost. So G is 4 irrespective of which path you are taking. So now what is in my fringe now? A and G. I see a goal state. I expand this. Am I done? How many of you don't get this? We start from S. When S is in fringe, I have no option. I have to just expand that. S is expanded. My fringe में A and B. G plus H here is 4. G plus H here is 3. So I take this path. I go here. I expand B. There is only one node connected to B, that is G. So my fringe में A and G now. A star cost is 4. A star cost is 4. I have a goal state here. So even if you go and explore it here, let's say G, what will be the value of G here? हाँ, sorry, right? So right now I have in fringe A and G. I have gone to a goal state and I am done. Is that the right thing to do? Of course not, right? So G star doesn't, I mean A star doesn't work like that. So it was not as easy as in the previous case. Okay, this was a good case for A star and everything was like कि हम सीधे इस G पे चले गए. All right, so we start again. So if I take A star the way we were discussing, we will DQ this path. So only stop when we DQ a goal. What does it mean? I have A and G here. I have explored G. Since I have DQ'd G, sorry, since I have seen G, that does not mean I have reached the correct goal. Okay. So only takeaway from this whole thing is, if you see a goal in fringe, that is not enough, right? In this case, I have put my goal in fringe and I see goal is in fringe, has the best cost, I am done. No. Shall I repeat? What will we do? I have goal in my fringe and that is also giving me the lowest cost until now. I stop. I mean, so this path, so the path that I will give is SBG and which is not optimal.
So like if we are following the path SVG, then the G cost for capital G should be 5. And then we can check it again, compare with A and G, right, which cost is lesser.
Tell me what is the definition of G? Do you see anywhere written here that the value of G is the cost of the path followed for that particular segment? No. It says uniform cost orders by path cost or backward cost Gn. So uniform cost is just one, which is 4. Say that again. That is even worse. See, अगर आप minimum cost की जगह if you are taking a bigger value, that's even worse. That's what UCS tells you. Because let's say if you were, अच्छा एक बार वापस fall back to UCS here. Forget H. Fall back to UCS. In case of UCS, so this is not there, this is not there, this is not there. Okay. So S, and in fact in case of UCS even G's are not there. Okay, I don't need, what I need is these costs. So I start from S, my fringe is just S, I expand S, I go to A and B, both are equally probable because remember UCS expands in the, I mean that same concentric circles. Cost 2, first let's say आपने A को explore कर दिया, doesn't matter. Now G is in my fringe. Will I go and explore G? No, not yet because I have a node with cost 2. उसको exhaust किया. Now I am done with A, I am done with B. My fringe is G. So which one do I take? This one. Right? Because इसमें tree कैसे बनेगा बना लो. S and then A, B, and then I have G, and then I have G. Right? So I'll take this path because cost here is 2, here is 2, here is 2, here is 3. So I'll go for this one. So what is UCS cost for this G? 4. Right? And what is my Gn? UCS cost for node n, right, G. Okay, so UCS cost for G is 4 or 5? 4. So we use 4. This one आप बताओ. In this case, so एक बार इसको हटाओ. What this slide conveys is we are tempted to do this, that the moment I have enqueued a goal, the moment my goal will come into fringe, I'll tend to think that I'm done. You are actually not. अब इसमें आगे कैसे तो अगर मेरी fringe में A और G था and if I declare कि I'm done, that is too soon to do it, right? Because अभी आप क्या करोगे? Expand A. Expand A and you will get to another G. That will take you to the right place. We'll see more examples. We'll see more examples. वापिस आ जाओ. करके देखो जैसे मैं ड्रॉ कर रहा हूं भाई. So you start from S. G cost बताओ. G is 0, G is equal to 4, G is equal to 1. So now अब इसमें क्या होगा? So S A G. What was this here? H equal to 7, G equal to 0. I am just writing the A star cost. 7. A की क्या थी? 7 and G is 5. 4. 4, right? So what will I do? In my fringe, I have this, I just go for this one.
सर लाइक जैसे अगर जी के पास पहुंचने के लिए वी हैव 3 मल्टीपल पाथ, देन जो उन तीनों में अपने पहले कैलकुलेट करेंगे कि उन तीनों में मिनिमम कॉस्ट जिसकी है वही अपना जी होगा, या फिर हमने उन पाथ को ट्रैवर्स करके देखेंगे कि कौन से पाथ के लिए मिनिमम आ रहा है.
That's a good question. So these are toy examples to see how A star behaves. In reality, you will not have this cost G for goal, because अगर आपके पास UCS cost for goal is already there, why do all this mess, right? So when I said here G is 4, I know it beforehand because it's a toy example. I can look at it and figure out what is the UCS value. But in general, when you are given a big graph, you have no idea what is the optimal cost. If you knew, we wouldn't be using A star. Okay? We are trying to see कि okay, we have just said use Gn plus Hn, and then we are saying कि इस algorithm की क्या glitches हैं. What are the things that we need to fix? So first, the thing that we fixed from this slide is, so let me bring the whole story. Right. In this case, everything was good, right? We did not encounter anything bad. Hn plus Gn was doing perfectly fine. We reached to the right goal. So this slide says A star works. This slide comes and says don't be too hasty. It's not as straightforward. And the catch in the learning from this slide is, if you have just NQ'd a goal in your fringe, that does not mean that the first one to NQ in your fringe is the right goal, right? So takeaway from this slide is, वो goal जो आपका पहले सबसे पहले NQ हुआ है, not necessarily कि that will be DQ'd first, because, right? So you have to wait until you DQ and not when you NQ. So a goal state has come in your fringe, that does not mean that is the optimal goal state you are looking for. Now this slide here. So now in this case, so which one are we going to DQ first? 7, 4? 4. So from previous slide we learned that DQ first, that's a good thing, but in this case now you DQ G first and you are done. But it's a wrong goal, wrong path. So even DQing first is not sufficient. You need something more. So now we are progressing towards what else do we need. So actual bad goal cost is lesser than estimated good goal cost. Difficult question, but can anybody tell me here what might go wrong? कहां पे गड़बड़ हुई होगी? यहां पे अपने पास दो ही चीजें हैं, G एंड H. G में कोई गड़बड़ है? Anything wrong with G? G is good old UCS, so that seems okay. It is H that is cryptic. Okay, so problems are with this H. And what does this say? Actual bad goal cost is less than estimated good goal cost. If it doesn't make sense, we'll see the simpler version of it. We need estimates to be less than the actual cost. That means your H, they can't be arbitrary. You have to choose H judiciously. Now we are going to put restrictions on H such that A star will always be optimal. Okay, so A star is not unconditionally optimal. Give me one value of H which will always work for A star. All of you can do that. Give me one value of H for all nodes in which it will always work. 0, right? Put H equal to 0 and this is same as my UCS, I am done. Right? So we did not prove optimality of UCS, it is done. I mean, of course, once optimality of A star is proven. So it is not yet done. Now, but H equal to 0, what is the problem with that? That throws you back to UCS and हम UCS से चले थे ये कह के कि we don't want to explore in this concentric circular fashion. We want to be more directed towards the goal. And who had this property to be more directed towards the goal? Greedy approach. So when you made H equal to 0, you have made that greedy component equal to 0. So now when you add these two, you are actually making use of both. But it is not a trivial thing to do. So we see what do we do next. So H was for heuristics. Not every heuristic will do it. A heuristic must be admissible for A star to be optimal. Now we talk about that. So inadmissible heuristic break optimality by trapping good plans on the fringe. Admissible heuristics slow down bad plans but never outweigh true cost. So if your H is admissible, then A star is optimal. So a heuristic H is admissible if this happens, where H star is the true cost to a nearest goal. Examples, so isko chodo, just concentrate on this right now. So what is H star? True cost to the nearest goal. In case of our Romanian map problem, what will this H star be? See, tell me, is H star known to us? It is true cost to a nearest goal, basically that optimal value that we are looking for. Is H star known to us? No, known to you? What is that value? If you compute, if you run UCS to compute H star, just stop there. Why? You have already found this value, you don't need to do A star now. Okay? H star is not known to you and we still have this kind of inequality. Any questions here? अभी तक जो भी लेक्चर किया है इसमें समझ नहीं आ रहा? ये वाली स्लाइड या पहले वाली? तो इसमें तो समझाया क्या अभी? Anything other than this one? Okay. What is H star? Optimal cost to reach nearest goal. But this is not known. So this is what we are looking for. I can't say I know it beforehand. But I am saying values of H should be less than or equal to this best cost. And it should be greater than 0. Now give me, so if this is my spectrum, H equal to 0 and H equal to H star n. We have already seen for 0. When H equal to identically 0 for all nodes, then we have UCS. So A star becomes UCS in that case. If I know the optimal value for all nodes, then I am at this extreme and I have basically solved the problem before beginning, right? So I don't know these values. I'm not supposed to know, because then what are you solving? So we are looking for a value of h that lies in between. Tell me roughly, where does value of h will be more effective compared to other values? See, if you are closer to 0, you are having more component of UCS. If you are having closer to h star, you are basically more towards a solved problem. So that's not the case either, right? So somewhere in between. I'm not saying it's the midpoint, because this scale might not be linear. Okay? So ज़्यादा इस तरफ हो, you are closer towards UCS. ज़्यादा इस तरफ हो, you are closer towards a solved problem, right? So somewhere in between lies a sweet value of h. Okay? What will that value be? अब इसमें ये देखो. So h की वैल्यू क्या होनी चाहिए? For every node, it should be the best cost path to that node, less than that and greater than 0. Questions? Can h be negative? Can you have negative h? नहीं, एक बार इस इक्वेशन को छोड़ो, अपने दिमाग से बताओ. Can h be negative? What is the, what goes wrong if h is negative? That will unnecessarily make my g plus h smaller. So you have actual cost g, but g plus h becomes smaller than the actual cost. I don't want that to happen, right? G plus h should be as big as actual cost, but it should not be bigger than this solved cost path, right? Because else it is not going to be optimal. So now these are admissible heuristics, in particular this one, right? This is an example of admissible heuristic. Tell me, assuming, so going from here to here, in presence of these mazes, will that cost be greater than 15? So your h is 15, it is greater than 0, and it is better than the, it is lesser than the best path. My best path would be so my best path would be this maybe, and 15 is certainly less than this, less than or equal to this. If I remove mazes, h becomes h star, both are 15. So this value of h should be smaller than the best way to reach to my goal. Which problem is more difficult? This board with mazes or without mazes? With mazes. So if you can reach to this point in, let's say, 22 cost, without mazes you will be able to reach there in less than or equal to 22. You certainly won't take more than 22. Done? So how do we find admissible heuristics? Relax these problems. H will come from a simpler version of the problem. ये थोड़ा सा डाइजेस्ट होने में टाइम लगता है. So any questions here? What is the best path? In this case we said 22. But is 22 known to me? नहीं पता. अगर पता होता, I wouldn't be solving this problem in the first place. But do I know for sure if I remove these mazes, this 15 is less than or equal to the best path? I am not putting a condition of strictly less than, it is less than equal to. For sure it is satisfied? Alright. So then this becomes a admissible heuristic. Admissible heuristic. Now you have to reason why is this a admissible heuristic for pancakes problem. What is the total cost to reach? The cost to reach to the optimal state from here, it will be at least 4, no matter what you do, because 4 1 is up there, right? So you will have to flip at least 4. You may need to flip more, but is this 4 giving you a lower bound? Right? Whatever best you are doing, it can't be better than 4. So 4 is a admissible heuristic here, H. Right? Because it is, so whatever best is there, it is less than or, sorry, it is greater than or equal to 4. You can't do it in better than 4, but you may take more. So this H star might actually be more than H.
But in this case, H star is
Feel free to yawn, sleep, eat, whatever.
फिर इसमें H star H ही है ना, मतलब pancake में।
H star, no.
इस केस में तो 4
इसमें बताओ, so if you flip this, what will you get? Biggest one, and then, so you need 3 more flips. So total cost will be 7. So H star is actually 7, but my H is certainly lesser than that H star. More questions here. इसमें भी मिड टर्म से क्वेश्चन आ ही रहा है, समझ लो. एटलीस्ट आज की स्लाइड से, आज के लेक्चर से. यस, H star optimal answer है in that problem, in that setting. So H star is optimal for this with mazes. हमने क्या कहा कि अगर हमको यही पता होता, I wouldn't be solving it. So I will relax this problem. I will remove all the mazes and I will say 15. Now whatever my original answer is, it cannot be lesser than 15. Because 15 is my Manhattan distance. So even if I remove all these mazes, I can't reach here in less than 15. So in original problem, I must be taking more. So that means this guy, let's say, is 22, this holds. Right. But we compute admissible heuristic by resorting to a simpler problem. Okay. So in this case, what was that simpler problem? Heuristic value was just the value of the largest pancake not in place. Right? In this case, the largest pancake that is not in its place is 4. Alright? So if H is admissible, then A star is optimal. Alright, so we get into this proof now. So pay attention here, अब इसमें थोड़ा सा दिमाग लगेगा. A star is an optimal. So these are assumptions. A is an optimal goal node. So this is the optimal goal node. Okay. B is a suboptimal goal node. What does this mean? So let us write down these things. What does it mean? Yes, so A is optimal goal node. What does it mean? How do I mathematically write that? How do I compare these two? G of A is less than G of B, right? It is clearly said B is suboptimal. That means G of A is lesser than G of B. H is admissible. So what does that mean? It will give me one more equation. What is that? H of A is lesser than or equal to G of A. Okay. A will exit the fringe before B. From last two slides जो अपन ने mistakes की थी, what were the two learnings from there? Stop A star when you DQ a goal and not when you NQ. Okay. So we need to prove that A will exit the fringe before B. Is this setting clear? Okay. So we go to next. So I am here. Imagine B is on the fringe. Why we directly have here imagine B is on the fringe? सीधे ही एकदम B होगा तो A भी होगा. Awesome. Because what we are concerned about is if there is a suboptimal goal in my fringe, right? इसके ऊपर क्या हो रहा था? We don't even care, right? So I have a suboptimal goal B on my fringe. What risk do I run? I might DQ B before A. So some ancestor N of A is on the fringe. Okay. So this guy and this guy is on fringe. And what do we need to prove intuitively? Ki DQing will happen in such a manner that this and we will DQ A before B. B was in fringe, it will remain there on fringe unexplored. Okay. So claim is N will be expanded before B because N is an ancestor of A. So Fn is less than or equal to Fa. ये क्या भाई समझाना यार मेरे को? Fn is less or equal to Fa. Fn is less than or equal to Fa. So this is my Fn, this is Fa. Why Fn is less than or equal to Fa? So let's see it here. Fn equal to Gn plus Hn. Fn is less than or equal to Ga. ये कहां से आया भाई? Fn is less than or equal to Ga. Fn is less than or equal to Ga. क्यों? Fn is less than or equal to Ga. Ancestor नहीं काम किया यहाँ पे. ये लिखा हुआ तो है. पिछली स्लाइड पे क्या किया था? 0 less than or equal to Hn less than or equal to H star. So no matter what this Fn takes, it can't take a value more than G of A. क्योंकि G of A तो optimal cost है to reach A. It certainly can't be greater than this. It can be of course much lesser than this, but it certainly can't be greater than this. Make sense? Admissibility की definition क्या थी? Lesser than the best cost. What is the best cost to A? G. So this cannot be greater than बेस्ट कॉस्ट, बिकॉज अदरवाइज तो एडमिसिबल ही नहीं रहेगा ना ह्यूरिस्टिक, एंड वी आर इंपोजिंग की एडमिसिबल है ह्यूरिस्टिक एच. ओके, नाउ जीए इक्वल टू एफ ए. Right. So in general this will be GA plus HA, but goal है so H of A is 0. FA is less than FB. Let me see if this gives you. FA is less than FB. Why? GA less than GB अपन ने पिछली साइड पे लिख दिया था. Why so? Because A is optimal compared to B, so GA must be strictly lesser than GB. FA lesser than FB because at goal H is 0, so FA is lesser than FB. FA is less than FB. N expands before B. N expands before B. Why? What is F, by the way? कितने लोगों को पता है what is F? एक बार raise your hands just. What is F? I might ask. So raise your hands only if you know. What is the value of, what is F here? G plus H. Okay. So Fn is less than or equal to Fa, which is less than Fb. Why so? Fa less than Fb तो बोल ही चुके हो ऊपर वाले में, right? Now Fn is less than or equal to Fa, ये उसके ऊपर वाले में बोल चुके हो. So this is done. All right. What does this mean? What does this mean? So we are done. मतलब वापस देखो. This is what we were looking for. A star expands in increasing order of F. So you look at this order, which node will be expanded first? N, because A star value for that is lesser. All ancestors of A expand before B by the same reasoning. A expands before B, and that's it. Questions on this? At least 60% of the class is not with me. At least 60%. So it's okay to ask anything. Questions here? इसमें अगर किसी को क्वेश्चन है तो कहां पे क्वेश्चन है भाई? Everybody is okay with this? All ancestors of A expand before B? Since nobody asked the question here. All ancestors of A expand before B. क्यों ठीक है बताओ? मेरे को नहीं समझ में आया. क्यों? राइट. Right? This inequality gives you everything. So n expands before A, and in everything A expands before B. So this n can A, so these two nodes can coincide as well, and even in that case A will be dq'd before B. क्वेश्चंस हियर. ए लेस देन बी कहीं नहीं हुआ दोस्त, या तो जी ए लेस देन जी बी हुआ था, एंड दैट इंप्लाइज एफ ए लेस देन एफ बी. सो जी ए is less than GB. Is that fine? Because A is strictly more optimal compared to B. So G value for that is lesser. Now what is F value, that is A star value? HA HB. Okay. So this is my FA and this is my FB. Now HA is 0. Why? Because goal के लिए H is 0. This is also a goal. H is 0. If H is admissible, yes. जो फर्स्ट गोल मिलेगा वो ऑप्टिमली होगा. That's why now we are saying कि A star is optimal. सो अब बताओ, जो पुराने जो फर्स्ट अपना एग्जाम्पल था जिसमें 2 2 2 3 था, उसमें व्हाट वेंट रॉन्ग? H was नॉट एडमिसिबल. दोनों केसेस में देखो हाँ. सो इस केस में भी देख लो एक बार. What now you can see what went wrong here. Can this H have value 7? Why? Because see, best part, so best G is 4. Your H can't be more than 4. So let's say एक बार H को यहां पे 3 रख दो and H को यहां पे 1 रख दो and see which way it goes. Right. And similarly for this one. Okay, H is admissible, you are done. I think it's a good point to stop for today's class. एक सेकेंड, अटेंडेंस नहीं हुई. स्लाइड्स ऑलरेडी हैं. I have to provide you recordings too, but देखो यार कब टाइम मिलता है.